MAP4C 7.0 Mortgages and Annuities Introduction. We're going to investigate the difference between simple interest and compound interest, both of which are methods of calculating interest when money is borrowed or lent. So, we can borrow money through a loan, and we can lend money, for example, to a bank through investments. Either way, simple interest is money that is earned on the starting principal. So the principal is a term that is used to describe the amount of money that is being deposited or borrowed. The interest formula for simple interest, I is equal to PRT, is I dollars is the interest earned, P is the principal or the initial investment, and R is the annual interest rate as a decimal, and T is the time in years. So I is equal to PRT. So this can calculate the total interest earned throughout the investment, and in order to find out how much is in the account altogether, we add our principal plus our interest. So the total amount of money is made up of the money that was borrowed or deposited, the principal, and the interest that's occurred from being deposited for that duration of time. So let's look at an example. Alan invests $1,000 into an account that earns 5% simple interest for 4 years. Use the formula to calculate the interest earned in 4 years. So we'll apply our guess method. What information is given? Reading through the question, Alan invests $1,000. That's the principal. The account earns 5% simple interest for 4 years. So the rate of interest is 5%. And remember that that is 5%. That means per 100. 5 divided by 100 is 0.05. And a decimal version of a percent is helpful for calculations involving percentages of an amount. It's invested for 4 years, so the time is 4 years. So the interest is unknown. Use the formula to calculate the interest earned for 4 years. So in order to do this, we have our given information. Our unknown component is the interest. Therefore, we use an equation involving these variables. I is equal to PRT. So our principal was 1,000. Rate is 0.05, and our time is 4 years. When we multiply these together, we get $200. $200 interest has been earned for depositing $1,000 for 4 years. What amount will Alan have at the end of 4 years? So we have our principal, $1,000 was deposited. We earned $200 in interest. So what is our amount? We can use our amount formula. Principal plus interest, $1,000 plus $200 is $1,200 altogether. $1,000 of which came from the individual, $200 was earned in interest. So it can be helpful to model our earnings in a table. So I'll try to include the question and this table in the window. So in the first year, we start off with $1,000 because we'll deposit $1,000 at the beginning of the year, and the interest earned is calculated right at the end. We'll take 5% of this starting balance. 0.05 is 5% of the amount, $1,000, which is $50. And our ending balance is $1,050 because that is our starting balance plus the interest earned during this period. So at the end of the first year, we'll have $1,050. The ending balance of this first interval at the end of the first year is the same as the starting interval for the second year. We'll invest all of that money into the account. But the interest earned for simple interest is based on the principal. It's always based on the initial amount that is borrowed. So we'll still take 5% of 1,000. That is going to be consistent for every single year. It will always be $50 interest earned. That's a key characteristic of simple interest. It always is based on the principal amount, so therefore it'll always be the same amount of interest. So that's why it is $1,100, an additional $50 at the end of the second year. And this pattern continues for simple interest. It is gaining $50 each year, which, as you remember from our previous unit, for equal intervals of the year X, we're having the balance Y increase by 50 regular intervals. This is a linear relation. So the interest is always the same because it is based on the principal amount. Next, looking at compound interest. Compound interest is money earned on both the principal and previous interest. So the interest that is accumulated throughout the process is being used in the calculation for future interest. This will be later illustrated in a spreadsheet. So the formula is the amount is equal to the principal times 1 plus I to the exponent n, where A is the total amount of the investment, P is the principal, the starting amount that was borrowed, and 1 plus I is the interest rate per compounding period. And we'll get more information about compounding periods momentarily. It just means that the calculation for interest is done at different intervals throughout the year. And N is the number of compounding periods, meaning how many times interest is calculated. We can use the same principle for our amount. This tells us the amount of the investment for compound interest. It doesn't tell us how much interest was earned, so we'll use the amount formula in the form of principal plus interest earned and isolate the variable I. To isolate the variable I, we would subtract P from both sides, so you would eliminate the P by subtracting it on the right-hand side, and then you'd have A minus P on the left-hand side. Switching those around, we get I is equal to A minus P. So this is a formula for calculating the interest. So Becky invests $1,000 into an account that earns 5% interest compounded annually for 4 years. A key component of compound interest is that it will say the interest rate, 5% interest compounded annually for 4 years. The key word is compounded, and it tells you how often. That means the number of times per year that we are going to calculate interest, and annually means once per year. We will need to adjust both our interest rate, I, and N to reflect the compounding periods. So let's look at our given information. We have our principal of $1,000, our interest rate at 5% per year, and the number of compounding periods. If you are calculating interest annually for 4 years, that is once per year for 4 years, 4. And what is unknown is the amount. So we use our given information and our unknown to find an equation that has all of these variables, and it is the compound interest formula for the amount. So we substitute in our values and solve, and notice that this is above the principal by $215.51. So the additional earnings come from interest. A way to formally write that calculation is, well, we have our amount, we have our principal, and we've solved for I using our amount formula, A minus P. So that difference from what we started at, the principal and the amount, is $215.51. That is the interest that has been earned throughout the duration of this investment. This is modeled in the table below, and it can give you a better understanding of how simple interest and compound interest operate. At the beginning of year 1, we invested $1,000 and we earned 5% interest. So that is $50 again, just like it with our simple interest situation. At the end of the first term, we have $1,000, which was our principal, and $50 earned to bring us to $1,050. I'm struggling with this, $1,050. Next, at the beginning of the second term, which is the second year, we have the same value as our ending balance. But this is where the difference between simple interest and compound interest occurs. 0.05 times the current amount in the account. So interest that is earned with compound interest is being used for calculations of interest in the future. So it doesn't look like a big deal. This is only a difference of $2.50. But this interest will keep accumulating and always be used in the calculation. So it will have an exponential growth over time. So our balance at the end of the year is the starting balance plus the interest earned, and our starting balance for the next term, which is year 3, is the same as the ending balance for the previous term. All right, 0.05 times the amount that is in the account. Think of it as the interest is being reinvested. And now it's $55.13 for the deposit for the third year. And we'll add up our values, our starting balance, and our interest earned to get our ending balance for this term. And this process continues. Notice that it's a slight difference from our previous example. This is $1,215.51, and that looks like it was up $15, and that doesn't sound too significant over the course of 4 years, of course, but looking at this graph, this is comparing both simple and compound with a T for some reason. So what I'm trying to highlight here is that the blue is simple interest. It's linear, growing by the same rate every single time. It was growing by 50 every single year because it's always based on the principal amount. It's always calculating 5% of that $1,000. Whereas with compound interest, the calculation for interest is based on the amount that is invested at the beginning of the term. So the interest is being reinvested. And if you're familiar with exponential curves, they start off with a rate of change being very gradual and then can eventually become a rapid growth. So investments in general, a good strategy are long-term investments to take advantage of exponential growth to see more dramatic changes. So things like your registered retirement savings plan, it's good to start early so that you gain the benefits of this exponential growth. And we'll investigate this later in this chapter. Next, I mentioned compounding intervals. Compound interest calculates interest on both the principal and the accumulated interest of the investment, as mentioned, and this applies strictly to compound interest, this concept. Annual percentage rate, APR, is the interest rate that is calculated throughout the year. And it's the standard to be able to talk about how much interest you're paying. But what we're going to be talking about is the compounding frequency, or number of compounding intervals that the annual percentage rate is divided into throughout the year. So let's use an example. What happens when you increase the compounding frequency? We'll use a principal. Let's say we borrowed $1,000 at an interest rate of $1,000. Well, 100%, which is 1.00 as a decimal. So I use this basic example so that it's easy to understand. We are using for 1 year annually. If we're investing or borrowing $1,000, at the end of the term, we'll calculate interest. That's 100% of the amount that was invested, and we would gain $1,000 in interest. Altogether, we would have the principal plus the interest. There would be $1,000 that was invested plus an additional $1,000 that was earned in interest, bringing us to a total of $2,000. Keep in mind that an interest rate of 100% is unrealistic, but it's a highly divisible number that is really helpful for instructional purposes. Guaranteed investments, so a guaranteed amount that is going to be paid or is low, such as 2%. So don't get your hopes up too much, but it's very helpful for this example. Semi-annually, that means twice per year. So it would still have an interest annual percentage rate of 100%, but it's broken up into 50% and then 50%. So the $1,000 is invested for the first term, which is the first 6 months, and interest is calculated on it, but we use 50% now, and $500 is earned in interest in this case. But the difference between simple interest and compound interest is we reinvest that interest, and then in the next term, we're depositing an amount of $1,500. And that is earning interest. So when we calculate interest the second time, it ends up being more because it has a larger amount that's invested. Initially, we just had 1,000. This time it's 1,500. So altogether, there's 2,250. So this is the exact same annual percentage rate as the previous example, but this is compounding interest semi-annually. Next, quarterly means that we've split the year into 4 equal intervals. That would be every 3 months. And at the end of each quarter, we're going to calculate 25% of the amount, because 25 plus 25 plus 25 plus 25 is still an annual percentage rate of 100%. So the interest rate at 0.25 times 100, we have $250 in interest earned in this first quarter. We reinvest that amount. We're depositing now $1,250, and that earns 25% of this amount that was deposited, and so on. And what we end up getting is, as the compounding frequency increases, the total interest increases. Why? Because the interest is accumulating and being deposited more frequently. So there's more money invested for a longer period of time. A separate video is made to further describe those compounding frequencies, but let's look at compounding periods. Interest is usually expressed as an annual percentage rate, APR. However, different compounding periods exist. So we're going to go in order. Annual is 1 time per year, semi-annual is 2 times per year, quarterly is 4 times per year, monthly is 12. This is all straightforward, but this uses or may require further explanation. Semi-monthly means 2 times per month, usually like the 1st and 15th. So that's 12 months in a year. It'll happen twice. That's 24 intervals. Bi-weekly is meaning every other week, every 2 weeks. And there's approximately 52 weeks in a year. So divide that by 2 and you get the number 26. So they're very close to being the same, but they're not the exact same concept. Weekly, there's 52 weeks in a year. And then daily is 365. And you could technically calculate interest continuously, but we'll leave that for higher education. So that being said, our interest value I must always be adjusted to reflect the interest rate at the compounding interval. So just as in our previous example, how we used 0.25 for quarterly when the interest rate was 100%, if our annual percentage rate was 12% and we were doing something, say, monthly, we would divide that by 12, and that would just be 1% at the end of each month. Next, present value. The principal that must be invested today to obtain a given amount in the future is the present value of the amount. The compound interest formula can be rearranged to isolate P. So this is the compound interest formula. Using opposite operations, I want P by itself. I'll divide both sides by 1 plus I to the power n. And this would be the result in the next line. It's common to express an isolated variable on the left-hand side. P is equal to A divided by 1 plus I to the power n. And this is our formula, which will tell us the principal that needs to be invested to get a certain amount at the end of an investment. This can be rewritten using negative exponents. Remember that a negative exponent makes you take the reciprocal of the base, and the reciprocal of 1 plus I is 1 over 1 plus I, and then we write that to the same exponent. So these are equivalent statements. Now, this is the exact same formula as before, just isolating P. Some people like to use this version of the formula, which is the exact same thing, where the principal is then called the present value, meaning the money that needs to be invested now, and the amount is the future value, what it will become. I like to keep things simple and just remember that this is all based on the compound interest formula, but this is something that you might see in the future and can be helpful to be aware of that connection. What principal should Cedric invest today at 4.6% per year compounded semi-annually to have $6,500 3 years from now? So this amount that's described is in the future. That's what we want at the end of the investment. So that's why I'll refer to this as the amount, using my preferred version right here. The amount that we'll have in the future is $6,500. The interest rate at 4.6 per year is compounded semi-annually. So I have to divide by 2 because at each compounding interval, it will be half of the annual percentage rate, which is 0.023. And 3 years from now, we have to think of how many times are we calculating interest if it's semi-annually, which is twice per year for 3 years. Twice per year for 3 years is a total of 6 compounding calculations or compounding intervals. So what we don't know, what is the principal that we need? So P is equal to A to the 1 plus I to the negative N. This is the present value formula. And we'll substitute in our given information. Notice that there is a negative exponent and that you must honor that in your calculation to get our final answer.